afternoon, everyone, and welcome to my talk about testing React applications. I have this very long German name. The most important part of it is Christian, so if you want to talk to me in the evening or tomorrow or on Wednesday, just call me Christian, leave out the rest. I'm a consultant for JavaScript and PHP. In the PHP terms, it's more or less architectural stuff. For JavaScript, I'm very much into React for a couple of years now. I think I started in 2016 with React, and I actually started developing single-page applications in 2008. Back then, it was not called single-page applications, and when I told people that I was creating classes in JavaScript, everyone hated me for it and told me, no classes, that's bad. It's wrong for JavaScript, and these days everyone uses ECMAScript 6 or TypeScript classes all the time. But yeah, we did that quite early. And these days we're trying to help companies develop React applications and fix issues in their React applications and make them testable. And I want to show you one of my favorite approaches on how to make a React application testable in this talk. If you want to talk to me afterwards, just send me in Twitter or email. My contact address is at the end. That's fine all the time. An alternative title to this talk, instead of testing React applications, would actually be, how do I create nice React components? Because the key to creating testable React applications is to follow some rules when you develop your components, when you structure your components. If you're into testing in backend stacks, most of the time people will teach you object-oriented design when they want to teach you how to test an application. And even though you don't have like the usual paradigms of object-oriented design with front-end components, the key again is to have clean code, clean structure to make your application testable. One thing before we get into the real topic, I do expect some knowledge in React. If you haven't seen any React code before, I have no idea how valuable this presentation is. Please let me know afterwards, because then I can say how valuable it's going to be. But I'm not going to explain a lot of React here. So when I first wanted to give this talk, it was at a meetup, and I thought I need a funny idea for an application that I want to test. I also thought, okay, this consulting thing is boring. I'm always developing other people's applications. I want to build my own unicorn startup, and my idea was, let's create a Twitter clone. So I sat down one afternoon and wrote a Twitter clone, which was very basic, but you could send tweets. Only one piece a person could. It did not have multi-user support, so it's very stupid. But I implemented it. Also looked very bad, because I'm very bad at design. You can look into the application afterwards. It's on GitHub. The URL to the repository is on the last slide, or just Google my name plus GitHub, and you're going to find the repository. And thanks to my friend Marcel, it doesn't even look bad anymore. I have this nice looking guy now. Fun fact, I told him, yeah, please, so this was my version and this is his, please fix everything that is below the black bar. I did not even think about that. This is looking very ugly now. But yeah, he made everything else very shiny. So let's talk about testing. Who of you has automatically tested an application before? Most of you, that's great. So if I ask you, what is easy to test? Does one of you have like a simple word, something that's easy to test? Business logic. I would partially agree. Why do you think business logic is easy to test? It's defined. It's defined. UI is difficult to test. Business logic is easy to test because it's defined. I actually think that the part that makes business logic easier to test, in some cases, it really depends on the business logic, is that we do have predefined results. We have rules, very strict rules that say, if this happens, this should happen. And to speak in a more technical way, I think functions are something that is very easy to test. If we talk about business logic, there's probably, if you're in a checkout process, there's some function that calculates the overall sum of a e-commerce cart, for instance. And that is a function that receives the cart and returns a sum. And the interesting thing here is that functions are easy to test when they're small, when they have a single responsibility, like this sum example that I had before. When they are pure, which means they receive some input, do not modify anything on the outside, and return some result. Also, if they're deterministic, so whenever they get the same input, they return the same result. This is something that makes code very easy to test. And this very often applies to business logic, you're right. And quite often it does not apply to UI components for reasons that I actually most of the time do not understand. Because if you think about the small parts of your application, most of the time you can split them up in small, pure deterministic parts. And that's what we're going to do today. So let's look at my application from before. Even though it is very small from a business value perspective, it is not from a perspective of an automated tester. Because we do have some logic to load tweets from the backend, to send tweets to the backend. We have this listing functionality that somehow iterates over the list of tweets that were received from the backend. We also have the side effect that you can add new tweets to the backend using the form. So that's not really easy to test. I gave out the keyword before. I think the important part to make this testable is to split it up. And this is what most React applications are normally structured. You don't have this one component that does everything. Most of the time I've seen applications, we shouldn't talk about that. So let's split it up. And the first easy part would be to extract this top bar thing that has no business value. So let's not gonna test it. It might have in your application, but I don't have a notification bar there or something. It's just a static text, static text, so there's really no value in testing it. We have this dialog for composing new tweets, and we have the list that probably also loads data from the backend. So let's look at the list. I don't think that it's small yet because it does not really have a single responsibility, because in many React applications, it would have the responsibility of loading data from the backend, which is one responsibility, iterating over the list of tweets, which is another responsibility, and then displaying those tweets. And this is something where in the real world, many applications would actually consider this just a single component. But I would actually take it a step further and I would say, okay, let's split it up even further. Whenever I have a list, well, to every rule there's an exception, but I'm still gonna say whenever I have a list, I do have at least two components. I have the list component and the list item component. Because then we have the outer component that kind of iterates over the entries, maybe still loads the data, we're gonna get to that later. And we have the inner component that has only exactly one responsibility. It receives a tweet, and it's supposed to display it in some way. And that, of course, is a component that is very easy to test because it's small, it's pure, it does not have any side effect, and whenever we give it some tweet, it will always display it exactly the same. Of course, for this particular component, that's not very complicated, as we're going to see in a minute, but this principle applies to more complex components as well. So let's dig into the code of that component. The usage of the component, in my case, would look something like this. So we do have this tweet list item component, and we give it a tweet, which is an object containing of a message, a user ID, an ID of the tweet, and the date represented as a ISO 8601, I hope, string representation. I'm a big fan of passing objects like this. You could also have 4 different props here, but I prefer objects, which is mainly because I prefer using TypeScript, and then it's fine to do it like this. If you're using React without TypeScript, I do understand why you would want to split it up, but it doesn't do anything for our cause here. So if I would render this tweet list item component, the result would look like this, only because Marcel made it look good. In my case, it was completely wrong. it would return us a list item, an HTML list item. Somewhere in there, there's an avatar with some service that renders an image, whatever. Here's the author's name, there's the text, and I don't even use the date right now. So that is very easy. That's deterministic, it's pure, it's small, it's quite easy to test. But what about the list? The list, I mentioned it before, might be a bit more complicated because the list is responsible for iterating and it might be responsible for fetching the data. And those are still two responsibilities. And now I want to mention a concept that made testing React applications and writing maintainable React applications way more obvious to me. And it's called component as a function of state. Who of you has heard of this term? Like 2, 3, 4 people. If you take anything from this talk, this should be it. The principle of component as a function of state says your component should be considered as something that turns your application state into a user interface. So function of means it's a function that is being called with the state in an abstract way of describing it. That means we should somehow handle the state of our application separated from the UI. With React, that's quite often done with Redux or Mobix or Mobix state tree or even GraphQL or whatever. And I think this is a very important concept because it does not really matter how we get to the state. The important part is our component only gets the state and is responsible for displaying some kind of a UI after transforming the state to HTML or to JSX, actually. And then there's another concept that probably some more of you have heard of, which is the difference between presentational and container components. And I'm going to first explain it. So presentational components are components that are responsible for displaying a UI. The tweet list item component we just saw is definitely a presentational component because all it does is it receives data and it displays it. Then we have container components, and container components are responsible for the logic of our application, for handling the data, for maybe fetching the data. And in the last years within the React ecosystem, nearly everyone was agreed on the fact that we should split up our components into these two categories of components, presentational and container components. Presentational components are quite easy to test, as we're going to see in a minute. At least most of them are. Container components can be a bit more complicated, but the nice thing is when we're talking about container components, we're not talking about UI anymore, which means we can test them in a way as we're used to testing from business logic testing or whatever you want to call it. An important thing to mention here is that one of the people who coined the terms presentational and container components does not think that we should separate our components like this anymore in the times of React hooks. While I do kind of agree, or let's say I kind of get his point, I don't really agree for now. I don't know how long you've been in the JavaScript ecosystem, but again, I was writing single-page applications 10 years ago, and the velocity that is in the JavaScript ecosystem of changing paradigms is insane. I've never seen this before, not somewhere else. So in JavaScript, people, like every new year, there's a new paradigm of doing things. And hooks might stay around, and they might still be the right solution in 3 years, but I wouldn't bet on it. And whatever solution we're going to have in 2 or 3 years is probably still going to fit into this presentation and container component thing. And hooks only, most of the time, are only responsible for the container component part. So if you still keep it split up like this, you can refactor it to the new paradigms in the future. Also, it's very important it's very helpful for learning how to structure code in React if you follow this paradigm. So I would really encourage you to do this. But instead of looking at containers, we're not a Docker talk here, so let's look into JavaScript code again. And I want to look into the code of our list item component before we get back to, oh, wait, that was the important part I wanted to tell you. So the list component that we had, we should split it up in a part that is responsible for the iteration and for the fetching the data. And we're going to do that in a second. And then it's easy again to test it. But now let's look into the test code for the list item first. Sorry for that hiccup. The list item component could look somewhat like that. We could also write it as a function component by experience that most people are more confident, at least right now, with class components. That's why I leave it like this. So it's a stateless class component. It only has a render method, takes the tweet from the props, and renders the data of the tweet somewhere in there. So here's the message, the user ID. Again, the user ID, quite boring. And for my tests, I kind of have a test fixture set up. An example tweet that I'm going to reuse within the following examples of testing that component. So the first thing to test when you're testing React components that at least many people say you should do is make sure that it renders at all. I don't really have an opinion on whether you should write a test like this for every component. There are people who say, you got to get started with it. If you want to be more pragmatic, I'm not going to kill you for not writing that one. But it's a good way to get started. I'm using a test framework here that's called Jest. You might know it. If you don't, it's quite straightforward. The only important part we need to understand on this slide is with Jest, you write it, then a name, then a function that executes the actual test. So we just created a test that ensures that our component tweetlist item renders without crashing. This is the name. And right here, we just create a div element. This is just DOM API. And then we call React DOM render, pass our component, and tell React DOM to render it into the div that we just created. What I find interesting here is the first time that I gave this talk again was at a meetup, and that was, I don't really remember what it was about, but there was before me a talk about testing Angular applications. And the code that the person needed to render a component in the test environment was insane. I don't want to do any Angular bashing here. Angular is awesome as well. But it took him like 15 lines of code just to set up some test bed and whatever. And with some cases of React, you can just say, OK, React DOM, the actual React DOM renderer, please render the component and then do stuff with the output. You're going to see we do have helpers in the React ecosystem as well, and they make stuff even more easier. And we also have tests that are very long. We're going to see that in the end. But this test makes sure that there's no exception during the runtime of our component that it renders. We did not verify that it rendered the tweet or rendered my name or rendered an avatar or whatever, but we made sure that it does not crash. The next test that I want to show is a bit more complicated and does a bit more stuff. And it's probably not the perfect test. What I do here is I render, again, have the div element. I render my component into the div. And then I fetch some DOM element from the div, the first child node, then its second child node, its first child node, its first child node. And I expect that it's in header 6 with the content Muriku, which is my Twitter handle. So what's bad about this? Except for a lot. I mean, more specific. Sorry? It relies on DOM structure. Why is that a bad thing? Moving it around will make the test break is kind of what you said, right? Exactly. This is a very, very fragile test. I've seen a lot of tests in the wild that look like this. Maybe not like this, but using some CSS selector or XPath expression or whatever. But those were all very fragile, because if I would have asked Marcel to make my application look fine after I created the test, that test would most likely break because he introduced more elements to my component. So this test works, but it will fail as soon as someone changes the component. That could be fine, but then again, if people changed the component, they need to change the test. And this has two implications. First, people will not look at failed tests anymore, because whenever they change something, they need to adjust the test. And they're getting used to, okay, I changed something, so I just adjust all tests and don't think about what's happening there. The second thing is, it's going to be a hell of a lot of work if you introduce a couple of more elements to your component, to fix this line of code. And it's probably some designer who's very good at HTML and CSS who's going to do the change, but is not that good at testing with Jest. So they're going to take like a minute to make the UI adjustments and then 15 minutes to fix the test. So they're going to hate the tests. And that is something that you don't want that. No one in your team should hate your tests. If they do, they won't write them, they will remove them, or they will just not change components that are tested. And you probably want no one to be afraid of touching parts of your application, especially because tests should help you with that. So I'm going to show you like the exact opposite approach of this. A test that in some cases might actually be a good idea. What I do here is those two lines, 32 and 33, are exactly the same like before. I just render my component with the predefined tweet. And then I just look whether somewhere in the rendered HTML is the string Mudiku, which again, my Twitter name. And if it is there, the test is going to be okay and it's going to be green. Does anyone have a problem with this test? You want to say something? So I understand what you're saying. What you're saying is you don't want to look for my Twitter name in here because it could be anyone's Twitter name. It is kind of more generic because this is the name that I put in here explicitly. So I say, please render a tweet for Mudiku. So it's fine to check in the test whether Mudiku is actually the Twitter name that is being rendered. There was somewhere over here. Yes? It's not strict enough. That could be true. So this test only verifies that somewhere in the HTML we do have the Twitter name. It might be a test that might be helpful, but it does not make sure whether it's rendered in the place where the username should be. It could also be somewhere in the text. For instance, if I would have used a fixture here where the tweet actually says, hello, I'm Mudiku, this test would succeed as well, even though if my username is not being rendered. So there are problems with this approach, but I do still like it for many cases because it's easy to write. Those are just 3 lines of code, and I'm not even using a helper here. It's not very fragile compared to the test before. Designers can do whatever they want about the structure. As long as my username is somewhere in there, this test is not going to break. So you kind of have to think about what is more important for testing a specific component. Do you need to make sure that the username is rendered within a header 6 element? If you need to make that sure, write a test that also verifies that Mudiku is written within an H6 tag. If you only want to make sure that somewhere in the output there's the tweet that I tried to send out, and somewhere in the output there's the username, then go that way. There's also one approach that is kind of the mix of the two worlds and taking both the advantages and downsides of both approaches that I want to show. That is called snapshot tests. Who of you knows snapshot tests? Many, but not all of you. Who of you has written a test, realized, okay, that the output is wrong, but I get the right output from the test here and copy it over to my actual test case. So your test runner tells you expected value would be this, but you actually rendered this, and you copy this actual over to the test case. Who has written code like this? I am quite sure that some people did not get what I was saying because it sounded weird, and others are not confident enough to raise their hand, because I've seen this so often. Snapshot tests kind of automate this way of testing. What we can do is, I'm actually using a different renderer here, but never mind that part. What I do here is, I say, renderer, please create the elements for this component, convert it to JSON, blah, 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 and expect that the result of that matches a snapshot. And what this would do is, it would create a file somewhere in a directory structure, like my test would be in source component, and then it would create a folder snapshots and put a tweet list item test.tsx as the file name of my test.snap, and it would create this file, and it would put stuff in there. And stuff means more or less the rendered HTML. And when we rerun the test, so when we run it for the first time, this file is being created. When we rerun the test, it will check whether the result of this call here is still the same. That means whenever, say, a designer would decide that we want to use the CSS class tweet list item here instead of tweet, then this test would fail. They would get a red bubble there. But Jest, the testing framework, would allow them to just update the snapshot. They just press a U on the console, or most IDEs like Visual Studio Code or JetBrains IntelliJ support snapshot tests, so they show you a small button that says, oh, the snapshot is not up to date anymore. This is the difference. Do you want to update it on the file system? And then you can say, yes, please update it. And what is important here is this file belongs into your version control system. You should commit it to your Git or Mercurial or whatever you're using. And if you do a code review, you should not only review the components and the tests, but also the snapshots. So what I like to do quite often is in teams that use snapshot tests, I primarily review the snapshots because, to be honest, well, there are very bad ways to write code, but if it has already been written, I don't really care how it was written, as long as the result is correct. There are, of course, places where it's very important that the code is written clean and you should look into it and so on. But most of the time, it's not worth the time and money to invest to discuss a lot of the implementation details, as long as the, let's say, output, the public interface on what was developed is correct. So looking into the snapshot is a good way to see what was actually changed there. Are there any questions or rants about snapshot tests or anything that I mentioned before? Yes?
There's not a risk to press too many times the U and keep updating without even looking at the difference from the previous one, which I think I've seen.
Well, you can press U as often as you want, as long as you look at the difference the moment you commit it. So the important part is when you commit it, look what did you change there. If you don't look in what you changed there, then you might have some problem in the process that people do not really take responsibility on what they're doing, which is, of course, a problem quite often, but this is a different topic. But it allows you to, for instance, you could say, okay, your designers are allowed to change whatever they want about the React code, but there has always some JavaScript engineer who is responsible to look over the change as soon as one of the tests or snapshot changes. So you can make visible what was affected by a change. So yes, of course, snapshot tests do not replace testing. Especially snapshot tests do not allow you to develop in a test-driven way, because in test-driven you should test first. And well, I would not want to write this by hand, especially because indentation matters. So no, snapshot tests are not always the perfect way to test things. None of these three ways that I just showed are the perfect solution for everything. You always need to think about, what do I need to make sure that should stay stable, that should not break. I'm going to show you an example on a way on how I like to do snapshot tests, where quite some other people actually say it's a bad idea, but I want to explain to you why I think it's a good idea when we talk about the list. So let's look at an implementation of the list. An implementation could look like this. It has a render method. It takes the tweets. It actually iterates over the tweets with the JavaScript map function and renders a tweet list item for every tweet that is there. If I would now create a snapshot test for this, it would look something like this, and it would go even further, and it's quite long, because it contains the output of, this is the list component, and somewhere down here, where does it start? There's the list item, sorry, there it is, list item. This is actually the code that is being tested from the list item component. So that test is very, very fragile, because whenever we change an implementation of the tweet list item, if we move the avatar around, that test is going to fail. What I like to do in cases like this is to use a so-called shallow rendering. And this is where people disagree currently, where there are some people who are saying, do not do shallow snapshot tests. What I do now is I use some other renderer here. This is, again, a testing library that helps you to do React tests. I think it's currently the most popular. It's probably not, I don't want to say whether it's the best one or not. It's right now, I think it's the most popular one. I'm going to show you an alternative at the end. And what I do here is I say, please render my tweet list in a shallow way, and make sure that this shallow rendered result matches a snapshot. And that snapshot would then look like this. So within the snapshot, we only have a reference to tweet list item. This is one tweet, and this is the other one. But we do not have the internals of that. So this is a snapshot where designers can change about the tweet list item whatever they want, but our tweet list test would not break. There are, of course, alternative approaches, again, on how you could test this tweet list. For instance, we could do this inner HTML contains blah, blah, blah stuff again. But, well, then again, we do have the problem that we do not verify the order of the elements. Then what I've seen quite often is that people write XPath or CSS selector expressions to fetch the tweet ID or user handle or whatever from the rendered list, and then convert it to an array of strings and make sure that this array of strings matches or whatever. But that test is quite often not readable. It's, again, a test that is not maintainable by designers at all, or actually not changeable by quite some React developers as well. If there's a CSS expression, CSS selector, I would most likely fail because I really, really suck at CSS. So it's not a perfect test either. So I think this is an approach that works quite well. Yes.
I don't understand why you render the component and then check. Basically, the component should return a predefined code, which you can check the output of the component, and not to render and then to check what is the result. For example, a tweet list will return you a specific content which will be rendered. You can compare this content and render it and then to match it against the snapshot or to match it against the DOM element. I mean, if you want to, if you render it, then you can use Selenium to test it.
That is an important thing. Now I got your point. So you're asking.
At least returns you HTML code. You can compare this HTML code with something.
I could just compare the generated HTML code by a tweet list. That's right, but that would contain a lot of HTML. It would not allow me to do this shallow thing. Also, you could also just use Selenium if you're doing this. The difference is, even though it is called render here, it's not, it was rendered in the slides before, and I called it render. It does not render within a real browser, but it renders in a Node.js environment that is very, very fast. So Selenium tests are useful for some cases, but in my experience, Selenium tests are quite slow, and they break when the temperature on your data center drops by 0.5 degree or something like that. From the way that you're laughing, is that I understand some people experience that as well. So they're very fragile. In my experience, they are. Not only by if you change code, but if something changes about your infrastructure. This test is not fragile. I don't say don't use Selenium tests. I say find the right mixture of tests. Selenium can be a part of this. This can be a part of it because it's fast, it's not fragile, and you get benefit from it. And it does not stand in your way very often. Was there another question behind you? I thought, no, okay. Okay, so this would be one way to test the tweet list. There are, of course, a lot of other ways. I mentioned the string matching. You could use the XPath selectors to extract parts of the rendered HTML, but I think this one is a very non-fragile way to test this component. Then we also have the component for writing new tweets. And I have an example on how that could look. I skipped the code of the component here because it doesn't really matter. The important part is we give that component a user ID, which is currently my name, and some function that should be called the moment that a new tweet was added. So we're using Enzyme again, the framework I used 2 slides before. And what we do is we now mount our component. We don't do shallow rendering. We don't do the render call from a few calls before, slides before. What we do, mount, which allows us to interact with the component after it was rendered. And what I do here is I mount the component, and from that mount, I do get a wrapper returned, which is some kind of a DOM element, more or less. And within that wrapper, I search for an element. I think this is CSS selector, so this is what I pretend to not know. And I look for an input element that has the name text, which should be the text of my tweet. And on that, I simulate a change event, blah, 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 blah. So this is very, very technical. There are, of course, libraries that would abstract that away from us, but I didn't want to introduce yet another library. So what line 18 to 20 actually do is, within the text box that is in our writing, tweet writing form component, I simulate a change event that says, okay, there should now be hello world within the tweet, within the input form. And then I could do this ensure that it contains hello world or whatever, or I just use a snapshot test or whatever you want to make sure that users can actually enter text. Because if you know React, you do know the concept of controlled components, and I always encourage people to use controlled components. And within controlled components, we are responsible for handling that if a user types, the results ends up in the form field. So that's why it makes sense to have a test like this. The next interesting thing would be to use this @tweet callback, which should be called when the user presses the tweet button here. So for that, I do have a test which again mounts my tweet writing form, simulates the change event, and then I simulate a submit event on the submit button. And then I do something that refers to something that you might have missed in line 27 because I didn't mention it. Right there, I create a so-called mock function with jest. A mock function is a function that does not contain any logic, but I can verify assertions on it with the help of jest. So the add_tweet callback that gets passed here is being reused in line 38, where I check that this callback should have been called once. And then the lines after that, I say that I want that it was called with an object that contains a user ID, which is my name, and a message, which is the message that I entered in line 34. Yes?
Would this work both on a functional component and a class?
This would work on a functional and on a class component, yes. And this way I tested the writing component as well. None of them were responsible for storing data or fetching data from a backend. And that is because I mentioned this considering components as a function of state principle. Because I think the code that I just showed you, if you have never seen testing of React code before, might seem a bit overwhelming, but it's something that after you got used to it, is very simple and is easy to understand. So we kind of covered this part here, but now we need to think about the part on the left, the state, which in my case here is being handled by Redux. If you don't know Redux, I'm very sorry. The basic concept is we do have a big state object that contains the state of our application, and we have actions that are not changes to the state, but that say, okay, something should be changed about the state. And then there's another thing that takes those actions and changes the state, but we're not going to cover that right now. I just want to mention the part of creating an action for Redux, which is an important part. And for that, I encourage everyone, if you use Redux, create so-called action creator functions. Never manually dispatch an action somewhere, but have a function that might look like this, where you return an object that represents your action. So I do have a fetch tweets action creator here. And within that, I have a type, which is the name of the action that is being emitted, and a payload. And in my case, the payload actually returns a promise. That is one way of doing things with Redux. I like to use a Redux middleware that is being called Redux Promise middleware. It will make sure that if I dispatch this action with the promise, I immediately get a fetch tweets _ pending action. And as soon as the promise resolves, I get a fetch tweets resolved action. And I'm going to show you the test for this. And warning, this is like the worst slide of the slide set because it contains way too much code, and this is probably the most complex part in this talk. So I'm going to use a Redux mock store library here to create a Redux store that is a bit easier to test. And then I have a test never mind that part. I have a test that should fetch data from the backend and store it in the Redux store. I create the mock store here, and I have a tweet example object, never mind that one. It's just like we saw it before. And then in line 27, I'm using a different library, which is called JustFetchMock. You can find the source code on GitHub, so it's easier to reproduce there, where I can just say, okay, fetch, so the ECMAScript fetch API, please mock a response once, and just return the JSON representation of that tweet here. So that way, I can do a fetch request within my tests, and I will get the tweet that I defined within the test as the response. And then there's the complicated part. On my mock store, I call the dispatch function and pass the dispatch function the result of my action creator that we saw on the slide before. And the mock store will then evaluate everything, will pass the action to the middlewares and so on. And when it's done, this callback gets called, and we can get the actions that were dispatched in the store, and we can then do assertions on that. So here in line 32, I make sure that the first action is an action of the type fetch tweets pending. I mentioned it before. This is the middleware that I'm using. And then we have a second action, line 33, which is the fetch tweets fulfilled action. And that one should contain a payload with one tweet that we defined in line 27. If you've never done React before, if you've never done Redux before, I'm sorry that you didn't get the last 3 minutes. That's fine for me. I'm very sorry about it. This is how you can test action creators in Redux. Testing reducers in Redux is something I'm not going to cover because reducers are by definition just pure deterministic functions. So they are very easy to test. They're from time to time a bit complicated to write, but they're very easy to test because they get state, they get an action, and they return new state. Okay, some last words. You already asked about function, sorry, do you have a question about the Redux part? Exactly, I'm testing the middleware more than the action creator. I am, in this case, testing a third-party library. The important part that I wanted to show here is that I'm testing my Redux, my Redux action creator in a way how they would behave in my application. If we look at this action creator, I would not test this one in isolation because, yeah, I mock away one function, verify that it's being called, return a predefined data set. I think that has no business value. But yes, your question was completely right. I'm testing the combination of the action creator plus the middleware. In cases of more complicated action creators, it makes, of course, sense to test them. But with this one, I would say don't test it. So you mentioned the function components before, and with function components, hooks are an important thing. I'm a consultant, and for me, it's important to teach stuff that I'm confident with and where I have experience with. And hooks have been there for a few months now. I have written a lot of code with hooks now. Testing components that contain hooks is completely the same as testing class components. Testing custom hooks is still a weird thing. The most efficient way to test them is have a dummy component that just reuses the hook, but I don't want to annoy you with that now. The question is, what about the real world? In the real world, in my experience, testing the way that I just showed it, with splitting up your applications, do this divide and conquer thing, think about the components and test them, and make sure that they behave in a way that you want to, is a very efficient way to increase the quality of your software in a big part. You mentioned Selenium before. With Selenium, you can go even a step further, but those tests, again, are very fragile. So I would recommend you have, let's say, 10 Selenium tests or something, but have hundreds or thousands of tests like this. Because if you have hundreds of thousands of Selenium tests, they're going to run it for hours or days, and they're going to fail every third time. So they won't help you that much. I also encourage you to look into Puppeteer Jest, which could be an alternative to Selenium, which might be a bit less fragile, but it only works with Chrome. So if you need to verify that everything behaves the same across all your browsers, this is not the tool you want to look into. But if you want to have something in the middle of, test the way that I showed, and Selenium on the other side, Puppeteer Jest might be a great solution. Who of you knows Storybook? Most of you, not all of you. Those who don't know it, Google it. It's an awesome thing. It allows you to develop your components in isolation outside of your application. So you don't need to press F5 in your application every time you change something, but you can just develop the application within Storybook as an isolated component. And then there is a plugin called Snapshots, which converts every storybook story that you have into a snapshot test. This might be helpful. It might also be incredibly annoying, but it might be helpful. I just introduced that with a customer who had problems that their storybook was broken every second day because someone did not look into it. So they now have that. They all agree we're just going to update the stories, but we see when they fail. There's also, I haven't used this yet in reality, but there's also a thing, Snapshots Puppeteer, which will take it a step further and will create images out of these stories and verify whether they match. Because everything that I just showed you does not take CSS into account. So even though if the HTML contains Moodiku, there might be some display hidden on it and you wouldn't see it. So this will help you if you want to test the UI, or the looking of it, but it will be, again, a bit more fragile. Last thing I want to mention, instead of Enzyme, you might want to look into React Testing Library and encourages good practices for testing, but it does not allow shallow snapshot tests. That's why I did not refactor the slides and the demo application to the React Testing Library. What's the key takeaway of this talk? The key takeaway is that clean components are easy to test. And that's why I called it testing React applications, even though I mostly talked about components. Because if you work on a good structure with components, testing your whole application will get a lot more easier. If you have more questions, I'm going to be around for another 2 hours, I assume, and I'm going to be here tomorrow and on Wednesday. Ping me on Twitter if you want to talk. This is my Twitter handle. There's also my mail address on it. Up here, you can see the URL to the GitHub repository, where you can see all the source code. I just need to push the changes that I did in preparation for today's talk, because in front of nearly every talk, I refactor stuff. So you can see that in, say, 10 minutes up there. Thank you for your attention. Have fun at the conference.